Hello students, welcome to Sreenath. In this video, we are going to discuss the third chapter, which is Understanding Quadrilaterals in 8th class CBSE Max subject. So, I am Karthik Kunne. We are creating videos on all subjects from class 6 to class 8. So, please do subscribe our channel. Also, like and share our videos. Let's begin this video. So, in this, now we are going to start this chapter. The chapter name is Understanding Quadrilaterals, students. Understanding Quadrilaterals. Okay, students, this is the present chapter. In this chapter, we are having almost 4 topics or 4 concepts. So, we are going to discuss 4 topics in detail and we are going to solve some of the examples in the chapter. Okay, students. So, now we are going to have the overview of the whole chapter. So, basically, there is an introduction. And introduction, there is nothing. This is the previous knowledge we have gained in lower classes. And the first topic is the polygons. So, what is meant by polygon and what are the different types of polygons and classification of polygons and diagonals and convex and convex polygons, regular and irregular polygons, and angle sum property of the polygons, and all those we are going to discuss in the first topic, students. And what is the second topic? The second topic is sum of the measures of the exterior angles of a polygon. So, sum of the measures of exterior angles. What are exterior angles and what is the sum of the exterior angles in a polygon? That what we have going to discuss in the second topic, students, and we are going to solve some problems in it. And after that, what it is? After the third topic, what is the third topic? That is kinds of quadrilaterals. So, our main name is, or our chapter name is Understanding Quadrilaterals. So, now what are the different types of quadrilaterals? Trapezium and kite. All these are parallelogram. All these are the elements of parallelogram and angles of a parallelogram. All these are the quadrilaterals kinds, types. Okay, students. So, that's what we are going to discuss. The diagonals of a parallelogram also we are going to discuss in the third topic, students. So, that is the whole matter in the third topic. Then coming to the fourth topic, that is some special parallelograms. So, what are some of the special parallelograms? That is rhombus is one type of parallelogram, and rectangle is one type of parallelogram, and square is another type of parallelogram. We are going to discuss all those in that topic, students. That's it. Our chapter is completed here. So, basically what we have completed up until now, we have completed the overview. Okay, students. So, our overview is completed here. Now, we will start our first topic. What is the first topic? We are having polygons. What it is? Polygons. So, what are polygons? This is our first question. What is polygons? So, basically, a simple closed curve made of only line segments is called a polygon. So, polygons are nothing but line curves, simple curves made up of line segments. Polygons are nothing but curves made up of line segments. We call it as the polygon. Polygon is nothing but a simple curve made up of line segments. What are the examples? These are the simple curves that are polygons. So, this is the one line segment, this is another line segment, this is another line segment, this is another line segment. So, these are the polygons, and these are not polygons. Why? Because means if you see, these are not simple closed curves. There are not simple closed curves. So, what is our main aim? That is simple closed curves. Simple closed curves. So, these are the simple closed curves, and the simple closed curves are formed by the line segment. They are not like that curved surfaces. They are the line segments. So, simple closed curves that are line segments formed by line segments is called as a polygons. Basically, if you see here, these are the closed curves, but this is not closed, and this is also not somewhat closed, and these are not closed, and these are not simple, and these are not simple closed curves. Even though they are made with the line segments, but they are not simple closed curves. That's the reason these are not the polygons, students. So, now you understand what polygons is. So, basically curves that are polygons. So, basically simple closed curves that are made by using line segments. We call it as the polygons, students. So, what is the classification of polygons? So, basically we have understand the definition of polygons, that is simple closed curves that are formed by the line segments. We call that as the polygons. And what are the classification of polygons? Based on the number of sides or the vertices, we have classified the polygons. So, if it is having 3 sides, we call it as the triangle, the polygon is a triangle. If it is having 4 sides, the polygon is a quadrilateral. If it is having the 5 sides, the polygon is the pentagon. If it is having the 6 sides, the polygon is the hexagon. If 7, then heptagon. 8, octagon. 9, nonagon. 10, decagon, and so n-gon. So these are the different types of polygons. And their sample figure is like that. This is having 3 sides and 3 vertices, 4 sides and 4 vertices, 5 sides and 5 vertices, 6 sides, 7 sides, like that. So this is the classification of polygons, students. What next? Diagonal. Next is diagonal. So what is the diagonal? A diagonal is a line segment. What is diagonal? Diagonal is nothing but a line segment. Line segment connecting two non-consecutive vertices of a polygon. So diagonal is nothing but a line segment, and that line segment is connecting two non-consecutive vertices. What are consecutive means? By this side, if the B and C are the consecutive, but non-consecutive means they are not the side by side vertices. So basically a diagonal is nothing but a line segment. It is connecting, that line segment will connecting non-consecutive vertices. So basically line segment, diagonal is nothing but a line segment which is connecting non-consecutive vertices of a polygon. We call it as the diagonal. Suppose if it is a quadrilateral. So now diagonal means a line segment. So a line segment is like that. These are the line segments, and from where to where this line segment is? This line segment is connecting non-consecutive vertices. So this is one vertices. These two are the consecutive vertices. These two are the consecutive vertices. But these two are not the consecutive vertices. So these vertex A and vertex C are the non-consecutive vertices. So there are two non-consecutive vertices, and these two are connected by a line segment. Of a polygon. This is the polygon, so we call it as the diagonal. So it is a diagonal. And if you take B and D, so B and D are also non-consecutive vertices. So a line segment connecting non-consecutive vertices, which means B and D, is also a diagonal. So diagonal is a line segment which connecting non-consecutive, which means which are not by the side of vertices. And in this case also, in the case of triangle also, what is the diagonal here? So in this case also, what is the diagonal here? So it is the diagonal. So this is the vertex, this is the vertex. These are non-consecutive vertices, opposite vertices, and like that, students. So basically this is not the actual diagram, this is the actual diagram. So this is a quadrilateral. It is having 4 sides. So these two vertices are the non-consecutive vertices, and these two vertices are the non-consecutive vertices. So this is the diagonal, this is the diagonal, students. So in this also, these are the non-consecutive vertices. So line segment connecting these two are the diagonals. So that is about the diagonal, students. And one more thing is, if you have a closed curve, what we have to know what the interior and exterior means. If you have a closed curve, the part which is inside the boundary of the curve is the interior. The part which is outside the boundary of the curve is called the exterior. Okay, students. So next is convex and concave polygons. So these are the convex polygons, and these are the concave polygons. So convex polygons. So basically in this chapter we are going to discuss this type of polygons only. These types of polygons has vertices outside. So basically if you see triangle, so this vertex is coming outward, this vertex is coming outward, this vertex is coming outward, and if you see this parallelogram like that, if you see it is coming outward, it is coming outward, it is coming outward, it is coming outward, or which is we can say convex polygons are nothing but whose vertices are coming outside, or whose vertices or endpoints are bulging out, we can say like that also. So all these are called as the convex polygons. So basically one more thing we know, that is polygons that are convex have no portions of their diagonals in their exteriors. So basically if you draw diagonals to it, all the diagonals will be on the interior, all the diagonals will be in the interior. So if you consider this, what are the diagonals? It is a diagonal and this is a diagonal. So what it is the interior diagonal. What it is exterior diagonal. So basically what convex polygons are? Convex polygons did not have no exterior, so exterior diagonals. So in the case of convex polygons, exterior diagonals are absent. There will be no exterior diagonals in the convex polygons. But in the case of convex, this is the concave polygon. Why? There are interior diagonals and exterior diagonals also, but this is a convex polygon. Why? There are only interior diagonals, students. Okay. And one more example for convex, is, suppose if you take this hexagon, if you draw diagonals, there will be like that. So all these diagonals are interior only, there is no exterior diagonals. So this is also a convex diagonal. So this is the concave polygon. Why means all are interior diagonals, but here there is an external polygon. And if you take this diagram also, what happens? You draw vertices, can you draw vertices like that? So diagonals like that. So this is the diagonal, this is the exterior diagonal. So where there is exterior diagonal, then we call it as the concave. Where there is exterior diagonal, we call it as the concave. Where there is an interior diagonal, so we call it as the convex. So that is the difference between convex and concave. Basically in the present chapter we are going to discuss about convex polygons only. And next is the regular and irregular polygons. So what are regular and irregular polygons? So basically regular polygons must have a equiangular and equilateral. What is equiangular means? Regular and irregular polygons. Okay students, regular and irregular polygons. So in the case, what are regular polygons are must having equilateral. What does it is? Equilateral and angular. What does it means? Which means same angle, same side. What it is? Same side, which means same equal side. Okay, suppose if you take this is the equilateral triangle. So in that triangle, all the angles equal to 180 degrees and all the angles equal to 60 degrees. So this angle is equal to this angle equal to this angle. So all the angles are same. So we call it as the equiangular. And this side length, this side length, this side length, these three side lengths are equal. So we can call this equilateral. So this is a regular polygon. What it is? Regular polygon. So if you consider this, the angles, this angle, all these angles are same. So equiangular, and all these side lengths are same. So that is equilateral. So this is also a regular polygon. If you say this is the 90 degrees and this is some not 90 degrees, it is some other degrees. So not angles are same. So it is not equiangular. So then it is not regular. It is irregular. It is having same angles, but its sides are not equal. So it is also irregular. Have you seen the dash on the? Have you seen the number? Here is one like that. But like that, what does it mean? Means whenever there is same like markings, then this side is equal to this side equal to this side. Whenever there is markings like that, we show that all these sides which are having marking like that are equal of length. So these are the regular polygons. Regular polygons means they have equilateral and equiangular, same angle and same equal side length. Okay students, so this is the equilateral regular polygons. Why? They are having same angles, all 5 angles are same, all 5 sides are same. They are having all 6 angles are same, all 6 sides are same. But here angles are different, sides are different. They are not regular polygons, they are irregular polygons. And whenever there is symbols like that, there is dashes on the sides, there means lines indicate line segments of equal length. These are having equivalent, students. Next, angle sum property. Angle sum property. What is that property? Basically, we know that sum of angles in a triangle equal to 180 degrees. If there is a triangle like that, then this angle, suppose A, B, C, then A plus B plus C is equal to 180 degrees. This is what we know in the previous classes, or this is our previous knowledge. Now we are coming to discuss about quadrilaterals. What it is? Quadrilaterals. So quadrilateral is also a polygon. Okay, polygon which is having 4 sides. So quadrilateral, it is nothing but a polygon having 4 sides. So this is a triangle. Sum of the angles in triangle. Triangle is nothing but a polygon having 3 sides. What is the case? What is the angle sum property in the quadrilateral means? So in this also, sum of angles in quadrilateral. What it is? Quadrilateral is 360 degrees. How many degrees? 360 degrees. Suppose if you take any quadrilateral like this, angle. So this is A, this is B, this is C. Then angle A plus angle B plus angle C plus angle D. All these angles must and should equals to 360 degrees. So this is the angle sum property. What it is? This is the angle sum property in the case of quadrilaterals. This is the angle sum property in the case of triangle, students. If you want a proof for it, suppose this is a quadrilateral. Okay, student, this is the quadrilateral which is like that. 1 side, 2 side, 3 side, 4 side. And what you have to do, you have to draw a diagonal at this, and you have to fold it like me. You have to make it like 2 triangles. Then what happened? Triangle ABC is ACD is one triangle. ACB is another triangle. So this triangle is having 3 angles, 1, 2, 3. So according to angle sum of angles in triangle, A plus B plus C equal to 180 degrees. Now this is another triangle. So according to this angle sum property, sum of the angles in triangle equal to 180. So 4 plus 5 plus 6 is equal to 180 degrees. Okay, students. So if you see, if you club all these angles, then these will give 180. This will give 180. So total what is how much? That is equal to 360 degrees, students. 360 degrees, students. So what happened finally? All the 6 angles in a quadrilateral equal to 360 degrees. Basically they are not the 6 angles, so you can combine both the angles. So finally this 1 angle, this 2 angle, this 3 angle, this 4 angle. So these 4 angles sum will gives to 360 degrees, students. This is the proof for sum of the angles in a quadrilateral equal to 360 degrees. You can do it in this example also. So angle at here, all these angles equals to 360 degrees. If it is having 4 sides, all these angles equal to 4. Suppose if you have drawn parallelogram, then this angle and this angle, all these angles equal to 360 degrees, students. So that's it, students. We have completed the first topic. Now we will start the second topic. What is the second topic? That is sum of measures of exterior angles of a polygon. So basically, students, this is the second topic. This is the topic sum of the measures of exterior angles of a polygon. So this is what we are going to find out now. So basically what we have studied previously means angle sum property. What does it says? That sum of angle sum property for quadrilaterals we have discussed previously. Sum of interior angles, sum of all interior angles in a quadrilateral is equal to, in a quadrilateral equal to 360 degrees. This is what we have learned previously. There is a quadrilateral like this, and this angle. So A, B, C, D. So angle A plus angle B plus angle C plus angle D, all are equal to 360 degrees. All the interior angles equal to 360 degrees. That is the angle sum property we have previously learned. Now what we are going to learn? We are going to learn some of the measures of the exterior angles of a polygon. So basically now we are going to study the exterior angles. What it is? Exterior angles. Exterior angles. Exterior angles. So suppose you have to suppose we have to start at one point A and goes along B and after that at that point this is the along line segment A B, and at that you have to make some turn with some angle 1. Angle 1 you can mark it as angle 1 and go some distance, and at angle C you have to again make a turn, that is angle 2. Angle 2, and again goes to a point D, and again you have to make a turn, and that angle is 3, and again at coming to that point again you have to make a turn, that angle is 4, that is E. Again you are whenever you coming to A, again you have to make a turn, that angle is 5. So now you can understand these are the exterior angles. So angle 1, angle 2, angle 3, angle 4, angle 5, all these are the exterior angles, and we can represent those as the M angle 1, M angle 2, M angle 3, M angle 4, M angle 5. So all these are the exterior angles. Okay students, so whenever we are going to add these all angles, that will give the 360 degrees. Why 360 degrees, sir? We have started at this point and you have again come to that point. Okay, so what you have to do, what you have to do is you have made one complete turn. You have made one complete turn. You have started here, you have made some turn, and you have made it finally comes to it, and again this to this path. So you have made a complete turn. So for complete turn, how many degrees are there? For complete turn means it is around 360 degrees. It is around 360 degrees. So all these angles are equals to 360 degrees, students. So basically, finally, what is the thing is sum of exterior or external angles. External angles of any polygon is 360 degrees. So this is a polygon. So sum of the exterior angles of any polygon is a 360 degrees. Why sum of any exterior polygons angles is 360 degrees means, so what you have done here, this is in this example, you have come to this point at what you have started, which means you have making a complete turn. So if you make a complete turn, what is the angle? What is the angle in angle for a circle or like that? That is about 360 degrees. So you have make a complete round turn, complete turn. Where you have started, you have reached to that point only. So you have made a complete turn. So how many angles you have changed is the total of the angles you have changed is 360 degrees. So that's why the sum of external angles of any polygon is 360 degrees. This is not only for quadrilaterals, this is also for, this is basically, this is not quadrilateral here. So this is for any polygon. So sum of the exterior angles of any polygon is 360 degrees, students. So this is what you have to learn. Why means you are making complete turn. In this example, we have to find out the value of x. So we have to find out the value of x. So this is the exterior angle, this is the exterior angle, this is the exterior angle, this is the angle. So all the sum of the exterior angles must be equals to how much? They must be equals to 360 degrees. So basically, what are the angles? This is 50 plus 90 plus 110. 110 plus 90 means 200. 200 plus 50 means 250. So 250 degrees plus there. What is the angle here? We don't know about that is x degrees. So all these are 250 degrees and this is the x degrees. So finally, what is the value of x? 360 minus 250. That is how much? That is 110 degrees, students. 110 degrees. So finally, we have find out the answer. So if he has asked the one of the exterior angles, you can easily find out it by in this method. Why? Because means sum of the all exterior angles is same. So if you want to find out one angle, then we have to equate the all angles to 360 degrees and solving that equation, you will get the answer. Okay, students. In this case also you can do it in the same way. Now Find the number of sides of a regular polygon whose exterior angle is measure of 840 degrees. So there is, we don't, so basically there is a regular polygon, so whose sides is equal. Regular polygon means having equiangular and equilateral, which means sides are same, angles are same. So each angle is same angle or equal, same angle, which means all angles are same, all angles are equal. One angle is 45 degrees, then one angle is 45 degrees. Then how many sides are there? This is the question. So total angle is 360 degrees and each angle is 45 degrees. Then how many sides are there, or how many angles are there? So that is nothing but 360 by 45, that is equal to 8 sides are there. So this polygon is having 8 sides. So for one angle that is 45 degrees. We don't know there are 360 degrees for how many angles, or otherwise. So basically 45 degrees, one angle 45 degrees. So now 360 degrees means there will be how many angles are there? 45 degrees means one angle, then 360 degrees means how many angles? That is simply we will get by 360 by 45, that is 8. So that is the answer, students. So we have completed the second topic also, students. Now we will start the third topic, which is kinds of quadrilateral. So basically quadrilateral means what? Quadrilaterals means which is having 4 sides or 4 vertices. We call those as the quadrilaterals. Quadrilateral is also a one form of a polygon. So basically polygon. So in the case of classification of polygons, quadrilateral is one of the polygons. Okay, students. So in the basing on nature of sides or angles, we have divided the quadrilaterals. We have divided or bisect, you have divided or separated quadrilaterals basing on the nature of sides or angles of quadrilateral. Quadrilateral are one is trapezium, another thing is kite, another thing is parallelogram. So these are the different types of quadrilaterals. Okay, students, how these are classified means basing on the nature of the sides or on the nature of angles. We have classified quadrilaterals into trapezium, kite and parallelogram. Now we will discuss about trapezium. So basically trapezium, if you clearly see, these are the trapeziums and these are not the trapeziums. Why these are trapeziums, why these are not the trapeziums means basically trapezium is a quadrilateral with a pair of parallel sides. So basically it is also a quadrilateral with a pair of parallel sides. So in the case of trapezium, what we are having, it is also a quadrilateral. So it has 4 sides. So like that. And what is the property for that 4 sides? These 4 sides, in out of the four sides, we have pair of parallel sides. So basically we are having 2 parallel sides. So out of 4 we are having 2 pair of parallel sides, means these 2 are the parallel sides, no? So in that 2 are parallel sides. And remaining 2 are not parallel sides. Only 2 are parallel sides. 2 are how you know 2 means pair of parallel sides, means there are 2 sides are parallel. So this side is parallel. So this is one type of trapezium. Okay, students. And another type is like that. So in this case, this and these are parallel. In this case, this and these are parallel. In this case, this and these are parallel. So trapezium is nothing but 2 sides parallel. Whenever 2 sides are parallel, then that quadrilateral is called as the trapezium. Whenever there is 2 sides are parallel sides, then we call it as the trapezium, students. That's it. In this case, it is these 2 are the parallel, but it is having 5 sides. It is having 5 sides, so it is not a quadrilateral. it is not a trapezium. So must and should trapezium must have 4 sides, and out of which 2 sides must be parallel. Then we call it as the trapezium, students. Okay, and one more thing is, if the non-parallel sides of a trapezium are equal length, then we call it as the isosceles trapezium. Isosceles trapezium. Suppose this is the one thing and this is the another thing. So suppose, so trapezium means it must have 4. It must have 4 it must have 4 sides. Trapezium means it must have 4 sides, and out of 2 they are parallel. 2 are parallel sides. Okay, students. And if another 2, this one is parallel to this one. In suppose if these 2 sides are equal, side lengths are equal. This is AB, CD. So here AB parallel to DC. Okay, students, that is one point. That is one point. Suppose if AD is equal to BC, then we call it as isosceles trapezium. Why upon isosceles triangle means because these are the parallel, this is the parallel sides, and there are non-parallel sides like this, and if these non-parallel sides length are equal, so basically suppose it is having, this diagram is like that. So this is parallel to this is, and these are not parallel. ABCD, AD and BC are not parallel. So then if AD's length is equal to BC's length, then we call it as the isosceles trapezium. Why? Because the non-parallel sides are having equal length. Non-parallel sides are having equal length. Then we call it as the isosceles trapezium. Normally if it is having 4 sides and 2 are if parallel, then we call it as the trapezium. So that is what about the trapezium, students. Next thing is the kite. Next thing is about kite, students. Okay, kite. So kite is a special type of quadrilateral. So kite is also a special type of quadrilateral. So the sides with the same markings on each figure are equal. Okay, students, basically this is the kite diagram. And this side are equal, and this side are equal. So in the kite it is having 4 sides, 2 sides equal, and 2 other sides equal. So if you take it as AB, CD, then AB is equal to AD and BC equal to DC. Okay, students, this is the thing. So it is having 4 sides, and out of which 2 sides are equal and another 2 sides are equal. So we call it as the kite, students. So what are the qualifications for a kite is, a kite have 4 sides, so it is a quadrilateral. And another thing is, there are exactly 2 distinct consecutive pairs. So there are 2 pairs, which means distinct consecutive pairs, which means they are by side, the 2 pairs are side by side. So this is one pair and this is another pair. These 2 sides are side by side. 2 distinct consecutive pairs of sides of equal length. So these side lengths are equal. So this pair of sides having same length, this pair of sides having same length, and these 2 pairs of lines are consecutive, means which are side by side. So then we call it as the kite. Kite has 4 sides, and out of which 2 sides are equal and another 2 sides are equal, and these 2 pair of sides are consecutive pairs. Okay, students. So that then we call it as the kite. Next thing is about the parallelogram. What it is? Parallelogram. It is also one type of quadrilateral. Why? Because it is having 4 sides. And if you consider the parallelogram, this is the parallelogram A, B, C, D. If you consider this, A, B is parallel to DC. So AB and DC are parallel, and AD and BC are also parallel. So basically parallelogram has in 4 sides and opposite sides are parallel. So in this case, opposite sides are parallel. In the case of parallelogram, opposite sides are parallel. This side is this side. These two opposite sides are parallel. These two opposite sides are parallel. Suppose if you want to draw a parallelogram, how you can draw? Take two cardboard sheets, rectangular cardboard sheets of different widths, and first take this cardboard sheet and mark it with pencil around its boundary, so it will like select it. Now take another cardboard, and if you place it in the horizontal, now you have to place it in the vertical, and again you have to draw like that. Then the one, if you remove the cardboard, the diagram is like that. Then we call this as the quadrilateral. So opposite sides are parallel. Opposite sides are parallel in parallelogram, students. That is the one thing you have to remember. And a parallelogram is a quadrilateral whose opposite sides are parallel. Parallelogram is nothing but parallelogram is nothing but a quadrilateral whose opposite sides are parallel. And elements of parallelogram. What are the elements of parallelogram? So opposite sides. So what are opposite sides? Suppose this is the parallelogram. Then these are the opposite sides. AD and BC are opposite sides. And AB and DC, AD and DC, all are opposite sides. And next thing is angle and angle C are a pair of opposite angles. So angle A and angle C are the opposite angles, pair of opposite angles. And what are the another pair of opposite angles? Angle B and angle D are the another opposite angles, students. And AB and BC are, suppose, so ABC. So AB and BC are adjacent sides. Okay, students, these are the adjacent sides. And here AB and DC here, DC, students. Opposite AB and DC are the opposite sides, and AD and BC are the opposite sides. Here AB and DC, these two are the opposite sides. Here AB, BC, these two are the adjacent sides, and these are the opposite angles. And what are the adjacent angles? Angle A, angle B. Angle A and angle B are adjacent angles. Okay, students, adjacent angles. And one more thing, important property you have to remember is the opposite sides of parallelogram are of equal length. So opposite sides of parallelogram are of equal length. Opposite sides of parallelogram are of equal length. So basically opposite sides, this is the one thing, these two side lengths are equal. So in a similar way, this is opposite, this is opposite, these two side lengths are equal. So this is the one more another thing, opposite sides are parallel and opposite sides of a parallelogram are equal length, students. Okay, this is one more thing property you have to remember. Find the perimeter of a parallelogram PQRS. So how can we find the perimeter of a parallelogram? Parallelogram is like that. That is PQRS. And this is 7 centimeters. Find the perimeter of the parallelogram PQRS, figure 3.2. So this is 7 centimeters and this is 12 centimeters. So basically how we can, what is the perimeter? Perimeter is the whole measurement from PQ. So perimeter is nothing but whole measure. So PQ plus QRS plus QRS. So PQ plus QR plus RS plus SQ P gives us the perimeter. Okay, students. So that's why this PQ is 12 plus QR is 7 plus how much this is? What is the value of RS? RS is equal to 12 centimeters. Why, sir? Means in a parallelogram opposite sides are equal. So this is 12 side. So this is also 12 side. So again 12 plus what is SP? PS is equal to 7. Why, sir? Means opposite sides are parallel. So this is the opposite sides. These are parallel and these are equal in a parallelogram. So this also 7. So again 7. So what is the total value? That is 38 centimeters, students. So in this way you can find the perimeter. So it is the perimeter. Perimeter is sum of the all sides. Sum of the all sides. Next thing is the angles of a parallelogram. Angles of a parallelogram. So if you want to find the angles of a parallelogram, what is the basically in the previous we have discussed about sides of a parallelogram. Opposite sides are equal sides. Now angles of a parallelogram. Opposite angles of a parallelogram are of equal measure. So opposite angles are equal here. Opposite angles are equal. Opposite angles are equal. This is the one more thing you have to remember, students. Opposite angles of a parallelogram are equal measure, and one more thing from previous thing is opposite sides are equal in a parallelogram, and opposite angles are equal in a parallelogram, and opposite sides are parallel in a parallelogram. So this is what we have learned, students. And now we are going to find out this problem. So basically this is the parallelogram. Find the values of x, y and z. So what is the value of x? If you clearly see, these two are the opposite angles. So opposite angles are equal. So angle B is equal to angle S. That is equal to, that implies angle B is 100 degrees. That is equal to x. So finally that implies x equal to how much? X equal to 100 degrees. And one more thing, we have understand this as the 100 degrees. Now this is the 100 degrees, this is the 100 degrees. Now we have to find out the value of y. So this is the value of y. How we will measure it? So basically this is the exterior angle, students. Exterior angle. If you see, opposite sides are parallel in parallelogram. So TS and BE. These two sides are the opposite sides and these two sides are the parallel in the case of parallelogram, and this is a one bisector. So if there is a two parallel angles which are bisected by some line, then the angle made by one of the pair of parallel line with that line is equal to the another line. So that's it, this angle equal to this angle. This angle equal to this angle. So this angle is how much? That is 100. So this angle is also 100. So therefore finally y equal to 100, students. Next, what about z? So this is 100, this is 100, students, and this is 100, students. Suppose this is the case. Okay, this is the 100 degrees, students. This is the A, students. So suppose if there is straight line, then how much angle it is? It is 180 degrees, students. Okay. Then if it's straight line, then how much angle it is? It is 360 degrees, students. We know about it. So if there is a, so how much angle it is? It is 180 degrees. So out of which here it is 100 degrees. Then how much angle here? It is 180 minus 100, students. So finally Z is equal to 80 degrees, students. Z equal to 80 degrees, students. So this is what? So finally Z equal to 80 degrees, students. So in this way we are going to find out the answer, students. One more thing is the adjacent sides in a parallelogram are supplementary. So here one more thing property you have to find out is adjacent angles are supplementary. Adjacent angles are supplementary in a parallelogram. So this is the one more thing you have to find out. So what are adjacent angles? This angle and this angle are this angle and this angle are adjacent angles. Okay, students, sum of the angles, adjacent angles, sum of the angles is equal to so adjacent angle means sum of the angles equal to 180 degrees, students. So basically this is what we have used here, which means in this case what happened, these are the 180 degrees. So if you bisect it, basically what we know is the total amount is the 180 degrees, and if you have any bisector like that, so this angle and this angle must be equals to, it is A, it is B, then A plus B equal to 180 degrees. So these two are the supplementary angles. So sum of the supplementary angles equal to 180 degrees. We call these two as the supplementary means 180 degrees. So these two are the adjacent angles. So sum of the adjacent angles equal 180. A and B are adjacent angles. A and B are adjacent angles, students. So sum of adjacent angles is 180 degrees, students. How much it is? Sum of adjacent angles is 180 degrees, students. So this what we have to learn about it. Sum of adjacent angles 180, which means adjacent angles are supplementary. Next thing is the diagonals of a parallelogram. If you clearly see, the diagonals of a parallelogram bisect each other. What does it do? Diagonals bisect each other. At the point of their intersection. Okay, students. So basically, this is a parallelogram and this is a parallelogram. Okay, students. This is one of the diagonal. This is the another diagonal. Those diagonals will bisect each other at the center. Okay, at the point of intersection, students. So if you want to prove it, we can simply prove it. How we can prove it? Suppose here A, B, C, D is the triangle. In the triangle quadrilateral or the parallelogram. In that parallelogram AOB triangle and COD triangle are similar according to ASA property, angle side angle property. These two are the similar triangles, equal triangles. Then what happened? If these two are the similar triangles, then A2O is equal to C2O. Then A2O equal to C2O, which means the O is the center of or the middle point of diagonal AC. So finally, O is middle point of diagonal AC. And if you consider this also, from these two triangles are equal, then BO equal to DO, which means again O is the center of BD. Again O is the center of diagonal BD. Hence, these diagonals are intersected at the bisect each other at the point of intersection, students. This very simple proof. One thing we have to remember is diagonals bisect each other at the point of intersection at the center. Okay, students. Now, HELP is a parallelogram. This is one of the parallelogram. Lengths are in centimeters. So this length is 4 centimeters. Given that OE equal to 4. So from O to E it is 4 and HL is 5. And from H to L is HL is 5 more than PE. Find OH. So how much here? HL is 5 more than PE, means 5 plus PE. HL equal to 5 plus PE, 5 more than PE. Okay, students. And OE equal to 4. So OE equal to 4, then PO equal to also 4. Since OE equal to 4, PO equal to 4. Then how much it is PE? From P to E, it will be 2 into 4, that is 8, students. From this to this, basically what we have studied, diagonals bisect each other at point of intersection, which means the point of intersection is the middle point of the two diagonals and it is having equal. Say from this point to this point is 4, then this point to this point is equal to 4, which why? Because it is the midpoint. So what is the total length? That is 8. So then what is the HL total length of this? Means 5 plus 8. HL is 5 plus 8. So that will becomes 13, students. Then HL becomes 13, students. Then what is OH? OH is the half of the 13. So that is 13 by 2. OH is the 13 by 2, students. In this way you can find diagonals of a parallelogram, students. That's it. We have completed this topic also, students. Now we will start fourth topic. Some special parallelograms. What are some of the special parallelograms, students? So if you want to know about this, let's begin this topic. So basically what are the some of the special parallelograms are? One is rhombus and another one is rectangle and third one is the square. All these are the sum of the parallelograms. First we discuss about rhombus. So basically rhombus, it is similar to kite. Okay, students. So how it will be? So basically rhombus, a kite is like that, rhombus is like that. Okay, basically in the case of rhombus, what we are going to understand, what are the things we have to remember is, so a rhombus is a quadrilateral with sides of equal length. So all sides equal, all sides are equal in the case of rhombus. But in the case of kite, these two sides are equal and these two sides are equal, but all sides are not equal. Okay, since the opposite sides of a rhombus have the same length, it is also a parallelogram. So In the case, if you clearly see, opposite sides are having equal length. Opposites have the same length. It is also parallelogram. So what is the condition for parallelogram? Parallelogram, opposite sides are parallel and opposite sides are equal. So it will may become parallelogram also, and it is having four sides. Quadrilateral also, it is having opposite sides equal length. So it is maybe parallelogram also. Okay, basically rhombus, in rhombus all sides are equal. This is the one thing, students. And also that of a kite. Okay, students, try to, you can now verify that your list with the checklist like summarized in the before else. Okay, in the rhombus all sides are equal, students. And one more thing we have to remember is the diagonals of a rhombus are perpendicular bisectors of one another. So basically diagonals are perpendicular bisectors. What are those? Perpendicular bisectors. So if you clearly see, what are the diagonals? This is the diagonal and this is the diagonal. So both these diagonals are perpendicular to each other. So it is in direction, it is in this direction. So both angle between these 90 degrees. So those are the perpendiculars and they are the bisectors. So basically the distance from this point to this point is equal to distance from this point to this point, and distance from this point to this point is equal to distance from this point to this point, which means that this length and this length are equal and this length and this length are equal, students. So for that, which means the diagonals are bisecting at the center. So it is a perpendicular and it is bisecting at the center. So for that reason we call it as the perpendicular bisector, students. All sides are equal and diagonals are perpendicular and diagonals bisect at center, which means this length is equal to this length equal to this length, students. Okay, students, that's what we have learned in the case of rhombus, students. Okay, now if you do some examples, so this is the rhombus diagram and we have to find the value of this x. Basically this is the length of one of the small half part of the diagonal. So from this point to this point is equal to this point to this point. So this OE is equal to 5. Why? Because means from this to this it is 5. So in the case of similarly, what is the value of z? Value of z, basically in the rhombus all sides are equal. So this side is 13, so this side is equal to 13, students. And what is the value of y? Basically in the case of rhombus the diagonal bisect at midpoint. So this length is equal to this length, so it will be y is equal to 12, students. That's it, students. And now we are going to discuss about rectangle. So rectangle is also having four sides, so it is a quadrilateral. So in the case of this also, opposite angles are what happened? Opposite all angles in the case of this. Opposite angles are equal. Or otherwise what we can write as? All angles are equal. And angles are 90 degrees. All angles are 90 degrees. Okay, students. So if a rectangle is to be equiangular, what could be the reason? So each angle is, what is the full meaning of that? A rectangle is a parallelogram with equal angles. Rectangle is nothing but a parallelogram with equal angles. This angle, all these angles are same, and all these angles, each angle equal to 90 degrees, students. So 90 degrees. So and it is having same equal angles. Okay, students. Now a rectangle is a parallelogram in which every angle is right angle. Okay, here every angle is right angle which is 90 degrees. So how it will look like? It is like that. So here everywhere it is 90 degrees, students. Being a parallelogram, the rectangular has opposite sides of equal length. So basically this side and this side length is equal. This side and this side length is equal. So rectangle maybe we call when the opposite sides are equal, we call that it as a treat that is as a parallelogram also, students. And its diagonals bisect each other. Basically if you draw diagonals, these diagonals bisected the midpoint, students. So it is having opposite sides equal and its diagonals bisecting each other. So we call it as the, we may treat it as rectangle, may be treated as a parallelogram also. Parallelogram also. Basically this is the rectangle. Next thing is, next property of rectangles, the diagonals of rectangle are of equal length. So basically it will bisecting at the midpoint. So this side is equal to this side. So diagonals. So and one more thing is diagonals are of equal length, and which means AC is equals to BD. From this AC equal to BD. Diagonals are equal. Diagonals are equal length, are having equal length, students. This is the one more thing property in the case of rectangle. All the angles equal to 90 degrees and opposite sides are equal. And one more thing is the diagonals are having equal length and diagonals bisect each other. Okay, students, this is what we have learned. So if you take the example of front, it is the rectangle. If its diagonals meet at O, suppose they are meeting at, find x value of find. Basically they are meeting at this point, and from this point to this point, this is 3x plus 1. So from this point to this point also 3x plus 1. So what is the total length of TN? That is equal to 2 into 3x plus 1. And one more thing is this point to this point, this point to this point is equal to this point to this point. So what is the total length of Rn? That is equal to 2 into 2x plus 4. And what is the another thing? Therefore basically in the diagonals are equal, and so these two are equal. So 2 of 3x plus 1 is equal to 2 of 2x plus 4, students. So 2 cancelled. So 3x plus 1 equal to 2x plus 4. 3x minus 2x equal to 4 minus 1. I have taken 1 to that side and have transposed 2x to this side. So 3x minus 2x equal to x. 4 minus 1 equal to 3. So finally value of x equal to 3, students. So this is the thing we have to remember in a rectangle. In the rectangles, diagonals are equal lengths. In the rectangle, all angles equal to 90 degrees. In the rectangle, diagonals bisect at the midpoint. And next thing is a square. Square, in the case of square, so it is having equal sides. All sides are equal. So we call it as all sides are equal. And one more thing is all angles are equal. All angles are equal and each angle is 90 degrees. And diagonals bisect at midpoint. Okay, students. And one more thing is they will bisect one another and are of the diagonals. Basically diagonals bisect one another and diagonals are having equal lengths and are perpendicular bisectors to one another. Basically therefore finally the diagonals of a square are perpendicular bisectors of each other. Therefore diagonals are perpendicular bisectors. Perpendicular bisectors, which means if you consider the square, this is not the square. So basically this is the square. So this is the diagonal and this is the triangle. These two diagonals are perpendicular to each other and they will bisect at the midpoint. So from this point to this point, length is equal to this point to this point. Okay, students. So this length is equal to this length and these two diagonals are also having same length, which means what happened? Which means this side length is equal to this side length, this side length is equal to this side, and this length, that is all these diagonals half what length is equal to, and this side is equal to this side equal to this side, and all the angles equal to 90 degrees, students. This is what in the square. All sides are equal, all angles are equal, diagonals are perpendicular bisectors, which means diagonals are perpendicular and diagonals are bisectors, means they bisect at the midpoint of the length. So that's what about the square, students. That is the thing about the squares. So that's it, students. So we have completed this topic also. So finally our chapter is completed, students. Chapter completed. Now we'll start the summary of the whole chapter, students. Summary of the whole chapter. So without wasting time, we are going to start the summary. So basically understanding quadrilaterals is the first chapter name, and it just first polygons. What are polygons? Means polygons are simple closed cells. formed by line segments. We call it as the polygons. So these are the simple closed line segments. They have closed segments. They are simple closed because they are formed using line segments. These are not simple closed curves. So these are not polygons. Next, polygons are different types. So if it having 3 sides and 3 vertices, it is triangular. 4 sides, it is quadrilateral, like that. In the what are diagonals? Diagonals are the nothing but the line segments. They are connecting the non-consecutive vertices, which means opposite vertices. These two are the opposite vertices. These two are the non-consecutive vertices. So line segment connecting opposite vertices is called a diagonal. So this is the diagonal. This is the diagonal. Convex and concave polygons. So basically, if there are no exterior diagonals, we call it as the convex. Basically, in this diagram, it is the exterior diagonal, so it is not convex, it is concave polygon. So if you consider this diagram, it is having only interior polygon, interior diagonal, so it is convex. And regular and irregular polygons. Irregular means having equilateral. Irregular means equilateral and equiangular. Equilateral means same equal side, same length. Equiangular means same angle. So if they having same angle and same side, we call it as the regular polygons. Otherwise, irregular polygons. And angles and properties. Some of the angles, interior angles in a triangle equal to 180 degrees. At the same time, some of the interior angles in a quadrilateral is also 360 degrees. Next is the sum of the measures of the exterior angles of a polygon. So basically, sum of the exterior angles of any polygon is 360 degrees. These are the exterior angles, and sum of the exterior angles is the 360 degrees. And sum of the interior angles of a quadrilateral is equal to 360 degrees. And kinds of quadrilateral means basically trapezium. Trapezium means it is having a pair of parallel sides. Trapezium means it is having pair of parallel sides. 2 sides are parallel, and the opposite sides are not parallel. And other 2 sides are not parallel. If it is having 2 parallel lines and other sides which are not parallel are having equal length, then we call it as the isosceles trapezium. And next thing is about kite. So in the kite, what happens? Two sides are having equal lengths, and other 2 sides are having another equal length. So basically, there are exactly 2 distinct consecutive pairs of sides of equal length. So this is one pair, which is in that pair 2 sides are having equal length, and this is another pair which in that 2 sides are having equal length. So these are called the kites. Next thing is the parallelogram. In parallelogram, opposite sides are parallel. In parallelogram, opposite sides are equal also. In parallelogram, opposite sides are parallel. In parallelogram, opposite sides are equal. It is having equal. And in the parallelogram, opposite angles are also equal. In the parallelogram, adjacent angles are supplementary. Adjacent angles of a parallelogram are supplementary. Okay, students. Next thing is the diagonals of a parallelogram. So basically, in the parallelogram, diagonals bisect each other, which means they bisected the middle point. Students. So next thing is some more special parallelograms, that is rhombus, rectangle, and square. Rhombus is similar to square, but what is this? In the case of rhombus, all sides are equal and diagonals are perpendicular bisectors. So basically, diagonals are perpendicular bisectors, students. In the case of rectangle, it is having 4 sides and all angles are equal and each angle is 90 degrees, students. Okay, students. And the diagonals are bisectors, and the diagonals are bisect each other at the middle point. And diagonals are having equal length, And in the case of sphere, all sides are equal, all angles are equal, diagonals are perpendicular bisectors, which means they bisect each other at midpoint, and they are also perpendicular to each other, and their length also equal. So that's it, students. Our chapter is completed. Our summary is also completed. If you like the video, don't forget to subscribe. Sreenath. Have a nice day. Keep smiling. Bye bye.